Hey, so today we are going to dive into the foundational things that we need to know when it comes to cells. So we're going to go ahead and dive into it, and we're going to start with the definition. What is a cell? So it says here that cells are the basic building block of all living things. So that means from the bacteria, little tiny prokaryotic cell, all the way to a rhinoceros, everything that is considered living has to have cells in it. So, how did we get to that conclusion? Well, there's a whole history behind cells. From Zacharias Janssen, he invented the first compound microscope. So, he basically created the microscope that we were able to take these things that we consider living, put them under there, and we noticed that there was these structures inside of the cells, and that every little thing, every living thing, had those little small structures in there. And they didn't come up with the name cell just yet. That was actually Robert Hooke, but they noticed that every living thing had them. And as you follow this timeline for cells, we end up coming with this thing called the cell theory. And it's basically saying, like, here are the three things that are true when it comes to cells and living things. These three scientists came up with these three components of the cell theory. The first one says that all living things are made of cells. If it is living, it has to be made of cell. Even if it's just one cell, right? It has to be made of cells. The second thing that has to be true is that cells are the smallest or basic building block of life. There will be nothing living that is smaller than a cell. Now, yes, we have elements like carbon and hydrogen. Those things are atoms and they're very small, but atoms or elements are not living things. Electrons are not living things. Cells are the smallest and most basic building blocks of life. And then the third and final part of the cell theory is that all cells come from pre-existing cells through cell division. So what does that mean? There's nothing in this world that will spontaneously come about that is living. If it is living, it has to already come from something that at least had one cell within it. So that is a cell theory, and this is true of every living thing when it comes to cells. Now that we know the foundational components of the cell and the cell theory, we're going to go ahead and zoom a little bit more into the cell. So, what have we learned over the years? We have learned that in most cells, there are these specialized structures called organelles that do work inside of the cell. So, I like to think of the cell as a factory, and the organelles are the machinery. Every machine inside of a factory, they all have different shapes, right? Their structures are different. Some are large, some are small, some have this many screws or that many screws. Because every machine in a factory is structured different, their functions are different. They all have specific purposes that are going to help to create and make this factory run the best that it can run. That is the same with organelles. Every single one of these organelles inside of the cells, they have different shapes, different structures, and their structures help them in their function. So I see right here that the nucleus is different from this vacuole structure here on the plant cell. Structures are different, function is different, but at the end of the day, they all play a role inside of that cell to help that cell live and function its absolute best. And there's going to be a whole lesson over what each of these organelles do. That's going to come later. So let's go ahead and dive into this question though. How did these organelles get inside of the cell? Because they weren't always like that. At least that's not the theory. The theory that came about in is called the endosymbiotic theory. And I actually want to break this word down because it really helps us to understand the whole purpose of this theory. So the word endo refers to like in, right? Inside. And then symbiotic refers to the relationship when two organisms or more are in close proximity. The endosymbiotic theory states that organelles, specifically the mitochondria and the chloroplast, were once prokaryotic cells and they were engulfed, right? Engulfed. So they were taken in, almost eaten, by a larger host cell, and they created a mutualistic relationship. So remember, mutual means that both organisms benefit. So even though I engulfed you, there's something that you provide for me that helps me, and there's something that I give you that helps you. So because it's mutualistic, it ended up staying that way. And every time they replicate it, they're like, hey, we're going to continue to keep you inside of here because we benefit one another. Let's go ahead and look at this image to make some sense. So here we have these prokaryotic cells, right? We see this one and this one. And we notice that they're taking inside, they're being engulfed. And over time, what they ends up turning into is what we know as the mitochondria in the chloroplast. So what do I know about the mitochondria? I know that the mitochondria take glucose, right, a food source, and it turns it into ATP, which is energy. By having this mitochondria, right, this bacteria that helps to make energy, the cell now gets more energy to do its functions. Now, what do I know about the chloroplast? I know that the chloroplast will take solar energy and some water and all that stuff, and it ends up making glucose, which is a food source for the cell. By engulfing these two prokaryotic cells, I now get more energy and I can get a food source. That sounds like a very mutualistic relationship to me. But this is also a really wild theory when you think about it. Like, yeah, this big cell ate two prokaryotes and they're like, you know what? We do good together. Let's work. It's really wild. So, what is the evidence that this actually happened? Because there is evidence that actually support this pretty crazy theory is one, mitochondria. And every time I say they, I'm referring to the mitochondria in the chloroplast. The mitochondria in the chloroplast have their own circular DNA. How is that absurd? Circular DNA is only for bacteria or prokaryotes. Our eukaryotic cell has linear DNA. So the DNA is different. If they were all together, came in one complete package, why would they have two different types of DNA? And why would the DNA that the mitochondria and chloroplast have match prokaryotes and not eukaryotes? So that's one thing. The second thing is the mitochondria and chloroplast, reproduce through binary fission. So they actually divide just like prokaryotic cells. But eukaryotic cells divide by a process called mitosis. And we're going to talk about that in a later unit. But they also divide differently. And the mitochondria and chloroplast actually divide on their own within a cell in a completely different way. The third thing is that mitochondria and chloroplasts have their own double membrane. This is the mitochondria, and as you can see, it says the outer membrane and inner membrane. The chloroplast has an outer membrane and inner membrane. Prokaryotes also have two layers. Prokaryotes have a cell wall and cell membrane. So it makes sense that if they went inside of this bigger cell and they were eaten, they're still going to keep their double membrane, right? But now it just serves a different purpose because over time they were in symbiosis. The fourth piece of evidence is that the mitochondria and chloroplasts have their own ribosomes. Eukaryotes have their own ribosomes, but the mitochondria and chloroplasts also have their own, as we can see here. And guess who else has ribosomes? Prokaryotes. So there's like four pieces of evidence now that support that these things probably used to be prokaryotic cells. And the last thing is that they function independently from the cell. Like there's so many things they do separate from the cell. And if the mitochondria and chloroplasts were always with the eukaryotes, then that means they should be doing things simultaneously with the eukaryotic cell. But we don't see that. What does all this tell us? These five pieces of evidence tell us that the mitochondria and the chloroplast used to be prokaryotic cells, and these prokaryotic cells were engulfed by a larger cell, and they ended up living in symbiosis, right? They ended up living well together and benefited one another. And I know that the mitochondria and chloroplast used to be prokaryotes because of these five evidences.